Hello everyone, I'm Mr. PSRB Shashank, Assistant Professor, working in the Department of CSE in the College of PV Raju Institute of Technology, Narsapur, and I'm going to deal with computational thinking and programming. In this lecture, I'm going to deal with introduction to arrays. Let us start with arrays. So what exactly is an array? We are dealing with different types of data types. We are dealing with single data types. We are dealing with integers. We are dealing with floating points. We are dealing with characters. But everything holds only one element at a time. Now, starting with our topic, introduction to arrays. So what exactly is an array? You can see it. Array is nothing but collection of similar data elements. Collection of similar data elements. Likewise, if I am taking just an integer, if I am taking an integer, if I am just giving it int a equal to 5. So this a is a variable which takes only one element at a time. In order to rectify that, if I want to store a particular record, set of marks of a student, I can use what? I can use an array. How I can use an array? I can use an array with similar data elements, with similar type of data elements, and those are stored in separate different memory locations, not exactly in the same location. Base address is same, but it will be stored in different type of memory locations. Or we can say it as, it is a collection of similar data items, same. We can say it as an element, we can say it as an item. Or we can say it as a particular data place, which are stored in continuous memory allocations with a single name, not with other type of names. As if I want to store details of a student, I need to use a single name and details of all marks 1, 2, 3, 4, like this. So that can be done using arrays. So what is an advantage of an array? Advantage of arrays, first thing is optimization of code. If I am writing more than one code, if I am writing int a equal to 5, if I am writing marks of a student int a underscore of something else, say of physics equal to 10, if I am saying a underscore mathematics equal to 20, if I am writing on continuously, it takes more lines of code. If I want to optimize that particular code, then I can use a concept which is called as arrays. And if I want to access the elements randomly, likewise, if I'm creating a physics, a maths, like that, if I'm creating a chemistry, if I'm creating n number of subjects or 10 to 20 subjects, like that, and if I want to access that subjects only for particular thing, if I just want to access a chemistry, I can access it directly using that particular name of that subject. But in your array, how to access that, we'll see it now. Applications of an array. Coming to applications of an array. First thing is, array is used to store list of values. As we have already said that array is used to store list of values. Which type of array? For that we use a single dimension array. And the next thing is, array is used to perform matrix operations. Matrix operations are done with dimensions. Matrix is nothing but dimensions. How many type of dimensions we have? Two-dimensional type. And we can have some sort of searching algorithms in an array. So what are searching algorithms? We have such as linear search, we have such as binary search, both the things. And we can do some sorting practices. Sorting practices is nothing but, if I want to sort list of elements, I have a different order, and either if I want to sort in ascending order as well as I want to sort in descending order, then I can use such sorting type of algorithms. In that we have bubble sort, we have insertion sort, we have selection sort, we have quick sort, we have merge sort, and all that. And using single dimension array, we can do some operations as stack. We can use some operations such as queues. We can do both type of operations, either it may be a stack type of operations or it may be a queue type of operation. In your using single dimension array, I can use for CPU scheduling algorithms in your operating systems. So array can be used at any type of things there. As we have seen, list of storing of list of values, matrix operations, searching algorithms, sorting algorithms, CPU scheduling algorithms. We have different type of stacks, queues and everything. We can use something called as an array. So how many types of arrays are there? We have normally two types of arrays. One is single dimensional array, second thing is multi-dimensional array. One is single dimensional array, second thing is multi-dimensional array. Single dimension is nothing but it has only one dimension. It has only one dimension. Coming to multi-dimension, more than one. It may be 2, it may be 3, it may be 4, it may be up to n types. That's nothing but more than one. I'll just write. So, what exactly is single dimensional type of array? Single dimensional type of array is nothing but a linear collection of data. Linear collection of data means it takes the data from a linear order, from the left towards to the right. In a particular order, if I am starting with the left part, it will take only up to the left part, to the right part. And two-dimensional array represents a mathematical matrix. Single dimensional array represents linear collection of data. Two-dimensional array represents a mathematical type of matrix. Now, how the memory is stored? How the memory is stored? Memory is stored in, again it is stored in a linear ways. How it is stored in linear ways, we will see that. So, before that we will see how to declare a single dimension array. There are three ways of declaration. This is the first way. Just giving a data type, array name and size. You can have an example for this. Data type, I'll have something called as integer. Array name is, I'll say student. Size, I'll give any size. I'll give size as 5. Data type, first thing is data type. Second thing is array name. Third thing is size. Coming to the next one, we can have an array with size and initial values. Size and initial values. First thing, again same data type, array name, size. We have the same thing. And we are giving some values to that particular array. This is just a declaration. This is we are giving some values. How I'll give some values? I'll give int student of 5 equal to something 10, 20, 30, 40, 50. As the size is 5, I am giving 5 values. And the next thing is syntax for creating array without size and initial values. Without size, if I am not giving size, how the compiler takes? You have a doubt. How the compiler takes? It takes based on the number of elements we are giving in that particular array. Like this. If I am giving int equal to something, some values. If I am giving 10, 20, 30. If I am giving 3 values. How much size this A will take? How much size this A will take? It's nothing but 1, 2, 3. How many elements are there? 3 elements are there. This will store A of 3. And every array is having 4 bytes. 3 into 4. It takes around 12 bytes of memory. Every integer is having 4 bytes. It takes 12 bytes of memory in that particular thing. And after this, you can have an example here. As we have seen it, int A of 3. And you can have int marks of 5. Array with size as well as initial values, and we can have array without size as well as initial values. In this, size is given and initial values are given. In this, just an array declaration is given. In this, there is no size given, there are only the initial values are given. So the size of this marks array will be 5 and total memory size will be 5 into 4. It's nothing but 20 bytes. It depends on the compiler. Size depends on your compiler. So, accessing elements in a single dimensional array. How we can access elements in single dimensional array? You can see it here. If I am having array like this. If I am having an array like this. This is an array. So, if I want to access elements from your array, I need index numbers. I need what? Index numbers. Look at this. If I am saying int A of 5, 10, 20, 30, 40, 50 are initial values. 10 is given, 20, 30, 40, 50. This is given to our array. This is equal to, I am giving like this. So first value 10 is accessed with a of 0. Why a of 0? Why? Because 0, 1, 2, 3, 4. Array index number starts with 0. Array index number starts with 0. When it will end, array index number will end at n minus 1. Array index number will end at n minus 1. Why it is ending at n minus 1? You can have a doubt here. There are how many elements are there? There are 5 elements. If there are size is 5, elements are 5. Index number is starting with what? 0. Index number will end at what? 4. So if the size is n, then the index number will end at n minus 1. If the size is n, then the index number will end at n minus 1. And if I want to modify some elements, if I am saying that I want to modify this list of elements, so if I want to modify them, so if I am giving a of 0, as we have the value a of 0 equal to 10, I am changing the value of a of 0 to 100. I am changing the value of a of 0 to 100. So I can directly change the value of a of 0 to 100. Yes. So if I am printing this a of 0, this will give a value of 100. Let me show you an example of in certain things of program, so that you can understand how you can take the values into an array and how you can print that particular values. I'm giving, this is hashing.stdio.h. This is nothing but a header file. After that, I have taken a main method. After this, I am taking an array. Int a of something 5 equal to 0. I'll give 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Now what I need to do, I need to have, and I'll give a semicolon here, I need to have a of 5, all the values to be printed. How I can print all the values? See, if I'm printing like this, printf, see, as %d, as this is an integer, I'm using %d. I'm just printing a of something called as 0. I'm just printing a of something called as 0. If I'm printing a of 0, this will give the value something called 10. This is a of 0. If I'm printing the next one in the same way, printf %d. If I'm printing something called as a of 1, this will give the value as 20. See, if I'm having 5 values, I can have 5 printf statements. Likewise, if I'm having 20, 30 values, it's not easy to print all the 20 values, 30 values, all the statements. For that, what we need to do? For that, we need to have a statement which is called as a looping type of statement. And in order to use a looping statement, there are different types of loops. You can use any loop there. You can use either a for loop, you can use either while loop, anything. As we know the number of elements, I'll use something called as for loop. So I'll take for I equal to starting with, see, as the index number is starting with 0, 1, 2, 3, 4. This is your index number of your array. As the index number is starting with 0, I'll start I value to 0. I'll give a semicolon. I need to stop I at 5. Either I can write I is less than 5, or I can write I is less than or equal to 4, or you can write I is less than 4 plus 1. In order to make sure that we are doing it very correctly, you can write directly I is less than 5. I equal to 0, I is less than 5, I plus plus. I is just a variable. You can have your own type of variable. For I have written for index there. So I is starting with 0. What I'll do, I'll just give a statement which is called as printf %d. So what I need to print first? I need to print first a of 0. Second, I need to print a of 1. Next, I need to print a of 2. Up to what? A of 4. I need to start with 0, 1, 2, 3, 4. In the middle, we have something called as just a of 3. So for that, what I'll give directly? A of I. So first I value is 0. 0 is less than 5, condition is satisfied. 0 is less than 5, condition is satisfied. Now it is entering into the block of for loop. It is printing percentage %d A of 0. A of 0 we have a value 10 there. So at the first iteration, it will print the value A of 0 as 10. In the next iteration, I plus plus, I is increased now. I equal to I plus 1, I can write it. So I value will be 1. 0 is replaced with 1. Now the next thing is what? 0 is replaced with 1. 1 is less than 5. And this will print A of 1. What is A of 1? You have A of 1 is, next thing is 20. So for the time being, I'll give \n here. So 20. In the next iteration, I value is increased to 2. So 2 is less than 5. Yes. This will print the next value 30. In the next iteration, I value is 3. 3 is less than 5. Yes. It will print 40. In the next iteration, I value will become 4. 4 is less than 5. Yes. So it will print what? It will print 50. In the next iteration, I value will become 5. In the next iteration, I value will become 5. If I value is 5, 5 is less than 5. So the condition fails. So it will come out of your for loop. It will come out of your for loop. This is just how to access all the elements of an array. If I want to access all the elements of an array, how to access all the elements of an array? So there is one more important thing here. Here we have taken the values of arrays in user-defined type of manner. Directly we have given the values here. Sorry, I'll say it as a predefined type of manner. What I have to do, I need to give the values. A user need to give the values. As this is predefined, and if a user need to give the values, then that could be like this. See, if I am giving the values like this, scanf, percentile %d, ampersand A of 0. This is for the first one. And if I am giving for the second one, scanf, again, percentile %d, this is ampersand A of 1. Again, this will take much time here. If I want to have 20 elements or 30 elements, it will take much time there. So if I want to use like that again, you can use a looping statement again. Which type of looping statement? Starting with I is starting with 0, I is less than 5, I plus plus. For loop I am using it. In that what I will do? For loop, scanf, percentile %d, ampersand A of I. Ampersand A of I. In the first iteration, I value will be 0. 0 is less than 5. So it will directly take what? Ampersand A of 0. It will give the value for A of 0 and it will store in a particular location. And the next thing is I plus plus, A of 1, A of 2, A of 3, A of 4. It will take from A of 0 to A of 4. This is how you can use your scanf statement and you can take the values into an array. You have taken the value into an array. If you want to manipulate that array element, manipulate is nothing but changing of the value of that particular array element. So I have given like this. So my array will be like this. I have given 5 values. I will give 11, something called as 12, 13, 14, 15. I have given 5 values here. So if I want to change the value of 13, I need to change the value of 13 to 130. If I want to change the value, then where is that location? Where is 13 stored? At which index number 13 stored? See, this is 0, this is 1, this is 2, this is 3, this is 4. So 13 is stored at a location which is called as 2. So it's nothing but A of 2. If I want to change that particular value, I'll modify that directly. If I want to modify it at single thing, A of 2 equal to 130. A of 2 equal to 130. And if I'm printing again that array, you'll get the answer as what? 11, 12, 130, 14, 15. This will be your array. So if you want to access your array elements, you can use it with your index. If you want to manipulate your array elements, again you can use that with your index type of elements. For that you can see it. if you want to access your array elements, you need to have an index which are enclosed in square brackets. Which are enclosed in square brackets. You have seen it here. Which are enclosed in which type of brackets? Square brackets. Now, we'll see one more important thing here. How to access your array elements is done. How to use your scanf is done. And the next thing, if I want to use like this, if I want to exactly know where is the memory location of your array will hold which type of memory location, then you can use like this. See. So if I am giving this 10, 20, 30, 40, 50. Now, this is name of this array is A. If I am starting with A, 0, 1, 2, 3, 4. These are your index numbers. Now, if I am just printing like this, if I am just printing printf percentile D, comma, ampersand A. If I am printing ampersand A, this will take address of A. This will print what? Address of A. Now, if I am trying to print address of A of 2, then I can give what? A of 2. Address of something called as A of 2. But what could be the address? You cannot directly say it. What could be the address? See, if I am saying my address of A is something called as 1024 and your integer is holding 4 bytes. Your integer is holding how many bytes? 4 bytes. Now, A is nothing but 1024. So, if I am saying like this, address of A is nothing but it will hold the address of A of 0. It will hold the address of A of 0. That's why we can say array will hold which type of address? Base address. Array will hold which type of address? Base address. Array holds directly base address. If I am saying that array holds base address, what is your base value? A of 0. So, A is 1024, A of 0 is also 1024. 1024. And I am saying that array is a type of integer. Array is holding which type of values? Integer values. And what I am saying, it takes 4 bytes. If it is taking 4 bytes, then A of 1 will be, next thing will be 1028. A of 2, next thing will be 1032. A of 3, next thing will be 1036. A of 4, next thing will be 1040. So, A of 0 will be 1024, A of 1 will be 1028, 1032, 1036, 1040. You can see there, the difference between A of 0, A of 1 is nothing but 4 bytes. That means this will take 4 bytes, after that this will take 4 bytes, this will take 4 bytes, A of 4 will take 4 bytes. So, memory allocation is nothing but it is giving a continuous type of memory allocation. There are two main points in this. First thing is array will hold which type of address? Array will hold an address which is called as base address. And the next thing is what? Array is having which type of memory allocation? We can say it as, you can directly say it as continuous, or you can give the name as contiguous. Both the things. So, this is your single dimensional array. In the next video, we'll see how to give the elements into two-dimensional array and how to access that particular elements, and we'll see how to print that in a matrix form. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.